Hello everybody, I am Patty and today I want to show you guys how I found the best way to handle ground detection in Roblox. I'll explain what I mean in a second. And this is my game Hunter's Instinct. I hope you guys can check it out. I'm releasing it soon for like all devices, and it's not fully ready yet and stuff like that, but I'm making it, and this is the game. So I'll show you what I had before. I actually made improvements to it. So as you can see, I have this move where I pretty much jump up and then I hit the ground, right? So I'll jump up and hit the ground. Now it might be hard to notice in the video, but there's like a slight delay, a slight like maybe like a few millisecond delay, and I don't like it. It feels unclean, it feels unsmooth. You see that right there, like the little maybe like 0.2 seconds delay? I don't like it. Let's fix it. Alright, so this is my initial script. So here we go. So as soon as it starts falling, we create two variables. This is my old script, so this is what we don't want to do. So pretty much we constantly check whether or not the player is hitting the ground by raycasting downwards. Now this is good because if you wanted to use like floor material by checking what the floor they're touching is, that's also another way of doing it, but it's very, very inaccurate and slow because of Roblox's systems. So this is what we have here. It works pretty well, as you can see, but it's not perfect. Alright guys, so now I'm recording on GeForce, so I kind of forgot I was using OBS, and OBS kind of sucks for like quality, so it'd be kind of hard to see the scripts. But now we're on GeForce, so I'll show you my new scripts. Alright guys, so this is my script right here. Starts right here. So we have a few same variables, but now we have the starting Y and the stored position. So I'll explain it. We can actually start right here. So we can ignore this function for now, but this is like the heart of this whole contraption here. So, alright, this is the first condition. So pretty much what we do here is as soon as the velocity of the player, of the humanoid root part, you can do this with other things probably too, but in this case we're just using the character model. If the velocity becomes negative, so if it begins to fall, then we track down that it went into high speed, meaning that now we can tell the rest of the code that we're ready to, you know, fire a function once we hit the ground. And then we store the starting Y. This is very important. We store the starting Y position of the player. And then I create a little part here so I can visualize it for you guys. And then here, we are going to make the rest of the script fire when it hits the ground. And then here we have whatever else needs to happen with all the debris and visual effects, if you guys want me to go more into that in another video. But here, so as you can see in this connection, in this run service heartbeat, every single time we're firing this function. So this function, pretty much, we create a raycast downwards, and as soon as we create the raycast downwards, we go, you know, pretty far. So it's guaranteed that it'll track down something for the player to hit, even if we're thousands of studs high. So we track downwards, and then we get a result, and this result position is saved. So the player falls down, or the player jumps. And then as soon as it hits the tippy top of their jump, we track down how far they're going to fall. And then now, we can use some physics. If you guys haven't taken physics, that's alright. You can just look at the script. And we can figure out, first of all, the delta distance, or the change in distance. So we have the starting position that we tracked earlier right here. And then we can subtract it by the Y position that we tracked by using a raycast earlier. Then we use a physics equation to figure out the needed velocity at the point where they're about to hit the ground. So pretty much how fast will the player be when they're about to hit the ground, and then we keep checking. So from there we're going to check if the character's velocity is less than, because it's negative. If it's less than the needed velocity, then we return true and we continue with the hitting effects and stuff like that. But if it's not, this is what really made it consistent for me. We track the time needed. So here we use the time needed using also a physics equation. And what we did was we took the needed velocity and divided it by the acceleration, which is gravity. And we're pretty much predicting how much time it's going to take before the player hits the ground. Now, I will say this, while being a lot more consistent than the last script I showed you, is a little bit inconsistent because this fires like every is a very short amount of time that it fires, but there's still that room for error. But this is pretty inerrant from what I've seen so far. So we get the needed velocity divided by acceleration, and then here we wait the time needed to reach that position, which we do at times 0.9 just to add a little bit of a buffer because, you know, this isn't perfect either. And then we're saying, pretty much here, we're saying if the position hasn't really changed at all, then go ahead and return true. So pretty much we're not relying on the velocity here, we're relying on if it's still the same target Y level, then we just wait the time that we calculated up here and we can get the distance found, and then we can return true. So I'll show you how that looks now. It's a lot more smooth, and let's see how it looks. Alright guys, so same spot right here. Alright, so guys, we do Z right here. We jump, and then you see how much more smoother that was? It might not have looked that much better, but it definitely is an improvement. And if there's ever something you want to do that's more precise, then this would definitely be the way to go rather than relying on Roblox's run service. So let's do it one more time right here. You can see a lot more smooth. You can play around with the buffer times, you know. Maybe if I did 0.8 instead of 0.9, maybe it'd be faster. But I hope this helped you guys. Hope these visual effects, you know, these markers showing where you stop and where you're aimed at helps you. If you guys enjoyed, please like and subscribe, and also check out my game, Hunter's Instinct. I'll link that in the description, and I'll link the code in the description too. Thank you guys. See you later.